anything here, it is understood to be what?
1. I mean 2. Sorry.
It is understood to be a square root, okay? Now, when we look at one with multiple pieces to it, we're going to break it up. So we're going to look at the square root of 54, the square root of x to the third, and the square root of y to the sixth, okay? So is 54 a perfect square?
No.
No. Okay, so whenever we have to simplify a perfect square, we have to figure out the biggest perfect square that 54 is divisible by to get like a whole number, right? So it cannot be divisible by anything bigger than 54, okay? Okay, so it can't be those, okay? So we look, is 54 divisible by 49?
No.
No. Is 54 divisible by 36?
No.
Is it divisible by 25?
No.
Is it divisible by 16?
No.
No. Is it divisible by 9?
Yes.
Okay. 9 times what gives us 54?
6.
Okay, so we can rewrite this as the square root of 9 times the square root of 6. What is the square root of 9?
3.
And then we can't do anything with the square root of 6, so we just bring it down. Okay, so that's the first piece. Second, we have the square root of x to the third. So when I look at a square root with a variable, okay, I have to figure out if this 3 is what? Divisible by 2. Is 3 divisible by 2? No. Okay, but can 2 go into 3?
Yes.
How many times?
1.
So we have x to the first with what left over?
1.
Now, when I write this, do I have to put x to the first power? No. We can just do x times the square root of x. Okay, now, we have the square root of y to the sixth. Okay? Is 6 divisible by 2? Yes. Okay? How many times can 2 go into 6? And would there be anything left over?
No.
Okay, so we just get y to the third. Okay, now we write the answer. Okay? When we write the answer, we take the parts that's outside of the radical and it stays outside. And we take the part that's inside and leave it inside. So what pieces are currently outside of this square root? 3x and y to the third. So we can write the outside part as 3x y to the third. Okay, then we have our square root. What parts will go inside of our square root? So we have 3xy to the third times the square root of 6x. Okay? So that is us breaking that whole thing up. Now we're going to look at the same thing, but we're going to look at a cubed version of it. Okay? So is 54 a perfect cube? No. But what is the biggest perfect cube that 54 is divisible by?
27.
It is 27. Okay? So we can split this up into the cube root of 27 times, what's the 27 times what gives you 54?
2.
Okay. Then we're going to do the cube root of x to the 7th and the cube root of y to the 9th. All right. What is the cube root of 27?
9.
3.
3. 3 times the cube root of 2. That is our first piece. Now, is 7 divisible by 3? But can 3 go into 7? How many times? So we have x squared times the cube root of what is left over?
X.
All right. Now, is 9 divisible by 3?
Yes.
Okay. So if 9 is divisible by 3, how many times does 3 go into 9? So we get y to the... Is there anything left over there?
No.
No. All right. So to write our answer, what goes outside the radical?
3x to the second and y to the third.
Okay, so we have 3x squared y cubed times the cube root of
2x.
2x. Okay, so that is how we evaluate a square root with numbers and variables in it, and a cube root. Okay, that's what we spent yesterday working on, and the day before too. Now we are going to talk about how radicals and exponents are linked today. Okay, so I just want us to take a second. Okay, you don't have to write this. This is just me before we start the lesson, us talking about it to see what we got going on. Because we actually already know how to do this. We've been kind of doing it anyway. So if I have some radical with a to some power n, okay, to find the answer of that, okay, if this has nothing right here, what is it understood to be? Yep. And then to find what the square root of a to the m is, what do I have to do with that m? I have to divide it by what? It has to be divisible by 2. So to evaluate that, we essentially say a to the m divided by 2, right? Okay, if this is a 3 right here, to get the answer, what do I have to divide that m by?
3.
Okay, that's what I've just did to do those two problems, right? What if this was some random number n? Over n. Okay, so what we can do with any radical is we can rewrite any radical as a rational exponent. A rational exponent is simply an exponent that is a fraction. And it's called rational because fractions are rational numbers. Okay, so on the top part of 6.2, we are going to fill in this first little part. Another way of writing a radical expression is that the radicand has an exponent that is a fraction. And remember, the radicand is just the base. Okay, and then it says given a is an integer, n is a positive integer, and m is an integer. Okay, we can say that a to the power of m divided by n is equal to, so if we have a fraction as our exponent, we can automatically know we can write it as a radical. And when we write it as a radical, okay, the base is what goes inside of our radical. Okay, then the power is what is at the top, okay, of the fraction. It will stay with the base. Then the n, what you are dividing by, okay, that right there is our root. Just like a tree, the root's at the bottom, okay? The root is at the bottom. And the root is going to stay outside, okay? But that is our pieces and how they go together. Okay, we can rewrite any radical as a rational exponent and any rational exponent as a radical. Okay, so if we look at rewriting one of these expressions, we can use the property of exponents and apply them to radicals as well. So anything we can do with an exponent, we can do with a radical, as long as we rewrite it first. Okay. So we're going to look at a few different types of questions, okay? And we're going to start with questions 1 through 4. So 1 through 4 asks us to write the following expressions using rational exponents, okay? So that means I am going to take these radicals and rewrite them to an exponent. So we're going to start with number 1. In order to rewrite it as a rational exponent, you need to know what the power is and you need to know what the root is. What kind of root is this? Square root. Okay. What power is understood to be on 5? 1. So to rewrite this, we will do 5 to the power of 1/2. The power goes up and the root goes to the bottom. Okay? Now, for number 2, what type of root do we have here? Cube root. Okay? And what are we taking the cube root of?
4x.
4x. All of 4x is being taken as a cube root. So our base is 4x. Okay? What power is understood to be on 4x?
1.
So it will be 4x to the what power?
1/3.
There we go. Okay? Why is it important that I put the parentheses around it? What would it be if I just said 4x to the 1/3?
It would only affect that.
That only affects the x. So the 4 isn't getting counted. We have to put the parentheses around it. Okay? For number 3, okay, what root are we taking here?
Square.
The square root, yes. Okay, so to rewrite that, what is our base? And it will be to the power of?
5.
There we go. Okay. For number 4, this is another way to write the 5th root of x to the 3rd. Those two things mean the exact same.
So why are we being extra parentheses?
Listen, you will not have this on your test.
Good.
It will be like this.
Great.
Okay? So how would I rewrite that? Take a second and rewrite that on your own real fast.
I'm scared. Oh, I like your earrings.
Thank you.
I had some like
Yeah,
that,
it's
but they were
not
like
like that.
orange, like crocheted ones.
Oh, yeah.
But I don't wear them.
Why not?
Because I like to wear like, I like stars.
Stars are fun. All right. How do I rewrite this? X to the power of what?
3/5.
All right. So that is how we rewrite them to rational exponents. Now we're going to write them the other way. Okay? So the next section has us taking the following expressions and rewriting them in radical form. Okay? So we are going to write these as a radical. So first thing you have to do is you're going to draw a radical. Now, what is the base of this? X. What is the root?
2.
What's the power?
1.
Now, is it necessary for me to write the 2 on that square root?
No.
Is it necessary for me to put the exponent of 1 on x?
No.
We could just say the square root of x.
Is it okay if we do that?
It is perfectly okay if you do. That's why I wrote it. If you need to do this just to help you not get confused, please do. Okay? It's not wrong. It's perfectly right. Just what you got over there? Oh, okay. Thank goodness. I really didn't want to get you on for your phone again. Yes. Yeah. I'm really on a roll this week. I've gotten somebody every day this week.
Oh, wow.
It's just every day this week. Yep.
Somebody say?
First period. You know. We'll not talk about it. All right. Now, okay. What is the base?
8.
What is the root?
3.
And what's the power?
1.
So that is the cube root of 8. What is the cube root of 8?
2.
2. Yay. 1? 2? Nora said it. No. Not that one.
All right. For number 7, okay, what is being raised to the power here?
XY.
Okay, so our base is xy. We have to keep it in parentheses, okay? Because what is our root here?
9.
What is our power?
5.
That power is going to both. So it has to stay in parentheses.
I don't like that.
I'm so sorry.
I'm really okay, I promise.
All right, so y'all go ahead and try to do for 8. Is x included in what's being raised to the power?
No.
Okay, so for this one, x is going to stay out front while you deal with the radical. Okay, so I'm going to give you a chance to do that. You tell me where everything goes. Give it a second. Fill it in. What's our base for the radical?
Y.
With a root of? With a power of? There we go. Okay, so xy to the 3/4 power is x times the 4th root of y to the 3rd power. Okay, so the reason you would want to rewrite these expressions is because you can simplify them further by switching between the two. Okay, it's kind of like how if you just had the problem of of 64 to the 1/3 power. Do you recognize what that is?
Yeah.
What is the cube root of 64 though?
It's 4.
4. So sometimes just having things written a different way makes it easier for us to recognize. Okay, and so we're going to go ahead and we're going to simplify some of the following. Okay, we're going to use a combination of our exponent rules and switching between the two. Okay, our goal is to get them with as few exponents and radicals as possible. Okay, so if we look at number 9, okay, for number 9, whenever we raise, so if I gave you x times y squared, what things are going to get squared?
X and Y.
Both x and y. So here, what things are going to get raised to the power of 1/2?
36 squared.
So we have 36 to the 1/2 power times, when you raise a power to a power, what do? Multiply. So it's like saying x to the 2 times 1/2. What is 2 times 1/2?
1.
Okay, and do I have to write that 1 right there?
No.
No. Okay, but I can rewrite 36 to the 1/2 as what?
Oh yeah, 18.
Okay, if it's a fraction in our exponent, we automatically are going to write it as a radical. We put our base inside. What's the root of this one? 2. Okay, what's the square root of 36? 6. And then did we do anything with that x? So we just bring it down. So the answer to that is just 6x.
Where'd the X go?
What x?
Oh, I see.
It's right here. We just didn't do anything with it, so we brought it down.
Okay,
Yeah.
that makes sense.
All right. Any other questions on that one? All right. So number 10. Okay. Same kind of setup. Everything is going to have to raise to the power of negative 1/3. Okay. So we're going to have 125 to the negative 1/3 power. And then we're going to have b 18th to the negative 1 power. So 18 times negative 1/3. What is 18 times negative 1/3? All right. Now, when we have a negative exponent in the numerator, where does it go? Flips and goes. Yeah. So we're going to put 1 over 125 to the 1/3 power and b to the 6th.
Why?
Because it's negative exponents. Negative exponents. So if I have x to the negative a, it will become 1 over x to the positive a. And if it's opposite, so if we have 1 over x to the negative a, it will go up and become x to the positive a over 1. It just causes it to flip. Okay? Now, for this part right here, okay, what type of root do I need to put 125 in? So we have 1 over the cube root of 125 times b to the 6th. What is the cube root of 125? 5. 1 over 5b to the 6th is our answer.
I don't like this. That's so much.
Okay? And we're going to drop to number 12.
Nice. So we're not.
We're going to go back to 11, but I want to do 11 last.
Oh my gosh, Miss Williams.
Yes?
How many of these kind of questions are going to get a quiz bomb? How many questions are
Maybe like
Great. We'll talk about it. There are going to be some, though. So we'll talk about it at the end. Well, as soon as we're done with the questions, we'll talk. Okay? We'll talk. I'll pull it up on my computer, and we'll talk about it. You can't see it, but I'll talk about it. All right. For number 12, okay? When we divide with two things with the same base, what do we do with the exponents? Subtract. So this is, let's saying, m to the 2/3 minus 1/3. Then we multiply by another n. What do we do if we multiply with the same base? What do we do to the exponents? So use your calculator and tell me what 2/3 minus 1/3 plus 3 is. 10/3. All right. Now, write that as a radical for me. So we put our base inside. What's our root? What's the power? Okay, now, just looking at this, it's kind of hard to simplify. But this, we know how to do that, right? How many times can 3 go into 10?
3.
So we have m to the 3rd times the cube root of how many is left over?
1.
So that's the answer. Yeah, but that tells us a little bit more about the actual number itself. Because 10/3, you have no concept of what 10/3 to the power of 10/3 is.
I mean the one after that. That one looks more simpler than what we ended up with.
This? Well, this is just taking it and breaking it apart. So if you had to plug in a number to it, this would be preferable because, yeah. All right. Now, we're going to look at number 11, everybody. Okay? So listen, okay? Listen. This looks so much scarier than it is, okay? So we know that if we raise something in a fraction to a power, everything has to get that power, right? I do not want to take and put 1/2 power on everything right there. That just seems like a lot, right? So why don't we simplify this fraction here first? Let's look at that first. Okay?
Let's look at the bigger picture.
Okay? What is 4/36 simplified? 1/9. Yep. Okay? Then we're going to look at the next piece. So x to the 4th divided by, or x to the 4/3 divided by x to the 2/3.
X to the 2/3.
Okay? What do you do with the exponents?
You subtract
So what is 4/3 minus 2/3?
2/3.
All right? Now, we're going to look at our y's. We have y to the 1/2. And just to make our life a little bit easier, why don't we change this to y to the 3/2? Okay? So we have y to the 3/2 divided by y. What is the exponent on that bottom y?
1.
So what is 3/2 minus 1?
1/2.
It's just 1/2. We get y to the 1/2. Okay? Now, we are going to take all of that and raise it to the what power? That's a lot easier. Okay? So, we're going to have 1/9 to the 1/2 power. Okay? Now, we're going to multiply 2/3 times 1/2. What is 2/3 times 1/2? 2/6. What can we simplify 2/6 to?
1/3.
Okay? What about 1/2 times 1/2? What is that?
1/4.
Okay? And now, let's rewrite this using radicals. I know. Okay? So, what type of radical? What will be the root of this radical? The root. okay, of 1/9. Okay? Then the next radical, it'll be x. What will be the root of x? And what will be the root of y?
4.
Okay? And we can only take one of those roots. Which one can we take? The square root. Okay? What's the square root of 1?
1.
What's the square root of 9? So we have 1/3 times the cube root of x times the 4th root of y.
Right.
Which is better than this.
Okay, I have a question.
Yes.
After
This part?
wouldn't you have to put that radical?
Yes, but you wouldn't have been able to get rid of these though. So you have to, it'll tell you to get rid of all of those. You don't want any rational fractions left. Yes. Yeah. Okay. So real fast, we're gonna quickly talk about our quiz. Okay. Okay. Now listen, the quiz. If you've done your delta math, the quiz should be fine. Okay? So you will have 6 questions of just straight exponent rules. Not combining a bunch of different exponent rules, just like doing one exponent rule at a time, pretty much. You'll have 6 of those exponent rules. You will then have 2 square root questions and 2 cube root questions. Okay? You will have 2 questions where you have to rewrite your exponents using this. And then 2 where you have to do the sum version of this.
Yay.
It is a quiz. It is. Okay. Okay. But if you can do the delta math, you will be fine. It is easier than the delta math.
Okay.
Okay. The delta math has bigger numbers, bigger chains of things happening. If you can do that, you will be fine.
Okay. What is the pressure bell?
Yes. So go ahead and work on delta math.
You have a new one today?
Yes, you do. It is 6.2.